The last goal today is going to be how do we add functions. So here in the margin, you see this f of x plus g of x. Again, a reminder that this f and this g is just a way to name different functions. So when you see this notation, the plus sign is what tells you that you're going to be adding two things together. Now you can also see this notation in the following way. You can also see it as functions f plus g of x. So this means the exact same thing. We're going to be adding these two functions together, and they happen to have a common input of x. Okay, with that notation then, remember that a function is a relationship where every input x is paired with exactly one output y. So for every input x, there's exactly one output y. So with that being said then, guys, in these examples, I give you a table of different functions. Here, all of their names, there's f, g, h, c, r, and t. And so I'm going to pose different questions for you that you're going to pull from here to actually compute. Let's start with example m. So example m says h of x plus r of x. Now first, to kind of get used to the notation, I can also ask you h plus r of x. That would be the same question. So get used to seeing this notation in different ways. But all it means is we're going to add h and r together. So I come to the table. H in this case is all of this. So it's 4x squared plus x minus 1. So it's 4x squared plus x minus 1. And we're going to add that with r of x. So r of x over here is going to be this function, minus 2x squared plus 9. So minus 2x squared plus 9. So in this case, notice how we're adding these together. And from our above notes, when we add things together, we can only add like terms. So as I scan these different terms, I see a 4x squared. So I see a 4x squared. As I look around, this is not an x squared. I see another one here, so I see minus 2x squared. So I can combine these two first, because they're like terms. 4 minus 2 is simply just 2. Remember, when you guys are going to add or subtract, you do not change the exponent. Okay, the exponent is the same when you add or subtract. Next, I see an x term here. As you scan the other terms that are left, there are no other x terms. So this x term here just comes down by itself, plus x. Then to finish, I see a minus 1 and a plus 9. So I can put these together, so minus 1 and plus 9, those are just constants, so 9 minus 1 is going to be 8. So this would be the result of adding together h of x plus r of x. Let's do one more example just to make sure it makes sense. So in example O, it says f plus t of x. This also just means f of x, so adding function f of x with function t of x. That's all it means. We want to add these two functions together. So again, f in this case is over here. It's 5x squared plus 3x. So I'll just copy that. 5x squared plus 3x plus t of x. So t of x is going to be, in this case, 8x minus 3. 8x minus 3. So in this example, now that I have it set up, remember that I'm only adding here, so I can only add like terms. So as I scan these 4 different terms, I have only one x squared term, so that comes down the exact same, 5x squared. But I do recognize that I have a 3x and a plus 8x. Those are like terms. I can put those together, and what I get is 3 plus 8 is 11x. You can notice how when I add, I do not change the exponent. And to finish, I have a minus 3. And because there's no other terms to combine that with, that's going to be my result.